Good morning, students. Myself, Vijay Shankar from EC Department, Chevron College. Today, we are going to discuss about the last topics in the 5th unit wave characteristics. It is surface impedance for a good conductor. In the last class, also we've seen that it's a surface impedance. Again, you can see what is the surface impedance and surface impedance for the good conductor and pointing theorem or the pointing vector. The surface impedance. The surface impedance is defined as the ratio of the tangential component of electric field, the ratio of tangential component of electric field to the surface current density at the conductor surface. It is defined as the ratio of tangential component of the electric field to the surface current density, Js, at the conductor surface. The surface impedance is noted as Zs and is given by Zs is equal to E tan by the Gs. Surface impedance is denoted as Zs and is a ratio between of the tangential component to the current density, surface current density, E tan by the Gs. So E tan is a tangential component of electric field which is parallel to the surface of the conductor. And the surface density is the linear current which is a result of the tangential component E tan. This indicates that the total conduction current per meter width flowing in the thin sheet. Okay, so the consider a flat plate conductor with its surface at Z is equal to 0 plane. Then the current distribution in the Z direction is given by J is equal to, J is nothing but the current density, and J naught is the current density at the surface, and e power minus j omega, e power minus not the j, propagation constant gamma into the z, where j is equal to the surface is at the z is equal to 0, and the current density passes through that surface. The current is passes through that surface, and we consider that the current is distribution in the z direction is given by the j is equal to j naught into e power minus gamma into z. So the exponentially decaying function, the j naught, the surface is like this, and z is equal to 0. The surface is placed a flat plate conductor. Note that the thickness of the conductor is assumed to be very large as compared to the depth of the penetration of a conductor. Depth of the penetration is nothing but the delta, so that the reflection from the backside surface of the conductor is not possible. Okay, note that the thickness of the conductor is assumed to be very large as compared to the depth of penetration of a conductor, so that the reflection from the backside surface of the conductor is not possible. Then the linear current density is given by the Js is equal to, you can take the integral 0 to infinite. It is a passes to the z direction from 0 to infinite, j naught into e power minus gamma into z dz. Okay, the surface current density Js is equal to the area under that surface. You can take from the 0 to infinite j naught e power minus gamma into z dz. So Js is equal to j naught into the exponential value e power minus gamma z minus gamma. The upper limit is infinite and lower limit is 0. So Js is equal to j naught into, when you can substitute the upper limit, it becomes of e power infinite is 0 minus, when you can substitute the lower limit instead of z, 1 pi minus gamma. The minus into minus is a plus here. Js is equal to J0 by gamma. So we got the JS current surface current density J0 by the gamma. Okay, and we know from the modified or Ampere's circuit law, the JC, the current density, conduction current density J is equal to sigma into E bar. Now the same thing we can take as in the tangential component J0 is equal to sigma into E tangential component. E tan. Substitute that J0 in the JS. JS is equal to J0 as a sigma into E tan by the gamma is gamma. So from that, you can substitute the JS in the ZS surface impedance, the ratio between the tangential component of electric field to the surface current density JS. What is the JS? We got E tan by sigma into E tan by the gamma. So E tan and E tan get cancelled. ZS is equal to gamma by sigma. Okay, ZS is equal to gamma by the sigma. And another thing you have to know, the gamma is equal to, because since we are considered as a conductor, gamma is equal to, we know, the j omega mu into sigma plus j omega epsilon. Okay. The propagation constant gamma is equal to in terms of the permeability, permittivity, and the conductivity and the dielectric constant. As the sigma is very much greater than the omega epsilon, neglecting the j omega epsilon here, gamma is equal to under root of j omega mu into sigma. Okay, I'm neglecting the j omega epsilon here. So gamma we got, then the ZS is equal to the surface impedance ZS is equal to, I'm substituting the gamma as j omega mu sigma by sigma. Here the root sigma is there and the sigma will get cancelled with the root sigma. Therefore that is equal to j omega mu and root sigma by the sigma is a root sigma. So you get the sigma. ZS is equal to under root of j omega mu by the sigma. Now this in this condition, the ZS, the surface impedance is equal to the intrinsic impedance. Why the intrinsic impedance, you know, the eta is equal to under root of j omega mu by the sigma plus j omega epsilon is a formula for the intrinsic impedance. As the conductivity is a more, using this equation here, the conductivity is a more compared to the dielectric, eta is equal to under root of j omega mu by sigma, because I am eliminating the omega epsilon comparing with the sigma. So now see here the j omega mu by the sigma is both are the same. ZS is equal to eta. The surface impedance is equal to the intrinsic impedance. Got it, my students? Let's see the eta is equal to j omega epsilon. Here the equations, it is clear that for a good conductor, the surface impedance of a plane of conductor with thickness greater than the skin depth of a conductor is equal to the characteristic impedance of the conductor. Okay, my students. Now the surface impedance for a good conductor, until then we completed this one, the ZS is equal to the eta. Surface impedance for a good conductor. Consider a conductor with thickness greater than the skin depth For the good conductor, sigma is very much greater than the omega epsilon. Then the surface impedance of a good conductor is given by, so here we got the surface impedance Zs is equal to under root of j omega mu by the sigma. Okay, we need to find the surface impedance of a good conductor. Conductivity is nothing but the sigma here. That is equal to, you can change this as j is under root and under root of j omega, not j omega, sorry, omega mu by sigma. So I'm rewriting this function as under root of j and under root of omega mu sigma. So under root of j means under root of 0 plus 1 into j. This is a complex function actually. Omega mu by sigma. So you can write the polar form for this one under root of 0 square plus 1 square, means the magnitude is a 1. And what is an angle? Internally we can write as under root only. Angle is tan inverse one by the 0. It's under root of omega mu by the sigma. So its magnitude is a 1, and in terms of the angle, under root of tan inverse 1 by 0 is an infinite, nothing but the pi by 2, under root of pi by 2, and root of under root of omega mu by sigma is nothing but the Js is equal. Okay, and similarly, so both it is also under root 1 with an angle of 90 degrees. 1 with an angle of 90 degrees is a under root of j, omega mu by sigma. When you can write the under root of angle 90 degrees is 45 degrees, and under root of 1 is the same. The magnitude is the same, and under root of 90 degrees you can write it as 45 degrees, means 90 degrees by 2, and under root of omega mu by sigma. Okay, my dear friends. We got the Zs is equal to under root of omega mu by angle 45 degrees. The angle 45 degrees you get as under root of j value only. So what is the angle 45 degrees? Means cos 45 degrees plus j into sine 45 degrees. The one with an angle 45 degrees is a polar form, and cos 45 plus j sine 45 is a rectangular form. Okay, multiplied with the under root of omega mu by the sigma. So what is it called? Cos 45? Cos 45 is a 1 by root 2 plus j into 1 by root 2, and whole multiply with the under root of omega mu by sigma. Multiply this function as Zs is equal to, so both are, it is under root only, under root of omega mu, and in the denominator root 2 and root sigma, getting into 2 sigma plus j into under root of omega mu by 2 sigma. This is Zs is equal to, we got omega mu by 2 sigma plus j into omega mu by 2 sigma. Okay. Then the real part in this expression, the real part in the expression for the surface impedance Zs is called the surface resistance. Is a real part, my students. The coefficient of j is imaginary part. Both are the same here. The real part in the expression for the surface impedance Zs is called surface resistance, and it is denoted as RS is equal to omega mu by 2 sigma. It is also called as high frequency or skin effect resistance per unit length of the conductor of unit width. It is also called as high frequency or skin effect resistance per unit length of the conductor of unit width. So remember, my dear students, these are very important for the online. And the imaginary part in the expression for the surface impedance, ZS, is called surface reactance. Okay, a real part is a surface resistance, and imaginary part of the surface impedance is called the surface reactance. That is also the same, but surface reactance we can represent it as a X of S, or X S is equal to under root of omega mu by 2 sigma. For good conductor, the skin depth delta is given by 2 by the omega mu sigma. See, we already know that is a skin depth delta is equal to for good conductor, delta is equal to under root of 2 omega mu sigma. Now the relation with the surface resistance can be expressed with the skin depth. See, what is a resistance surface? RS is equal to under root of omega mu by 2 sigma, and delta is equal to, delta is nothing but the skin depth, under root of 2 by omega mu sigma, 2 by omega mu sigma. Now you can relate these two functions. RS is equal to, in terms of the delta, so delta is equal to 2 by, so the RS is equal to the inverse. You can take this as a 1 by delta is equal to, what is a 1 by delta now? 1 by the delta is equal to under root of omega mu sigma by the 2. Okay, my dear students. It's a 1 by this function, omega mu sigma by the 2. So here the sigma is there, omega mu, okay, 1 by delta is nothing but omega mu and the 2. To get the denominator as a sigma, we can multiply here, that is a, you can multiply with this function as sigma, 1 by the sigma. Got it, my dear students? Then the root sigma by the sigma is nothing but the 2 sigma. So 1 by delta is multiplied with the sigma is equal to the surface resistance or surface resistance. This total function is delta. It's a delta function. Now I am multiplying the sigma also. So 1 by the sigma, delta into sigma, it becomes of under root of omega mu. The root sigma here and the denominator is the sigma, will get as 2 into sigma in under root is equal to RS. So RS is equal to 1 by delta into sigma. 1 by delta into sigma. It's a very, very important relation, my dear students. The surface impedance of a good conductor, the real part is called as surface resistance, and imaginary part is considered in the expression is a surface reactance. It's called as a surface reactance. Okay, and the relation between of surface resistance and the skin depth delta is RS is equal to 1 by delta into sigma. Okay, my dear students. Now you can, if any given the skin depth and the surface resistance of the copper conductor at 100 megahertz having the conductivity sigma is equal to and mu r is equal to given. Delta is equal to the 2 pi omega mu sigma. Omega is a 2 pi f because the f is given here 100 megahertz. Mega means 10 power 6. And mu, in that the mu r is given is 100. So mu naught we know 4 pi into 10 to the power of minus 7. 4 pi into 10 to the power of minus 7. And conductivity is also given 5.8 into 10 to the power of 7 ohms per meter. That is equal to, substitute all the equation, all the terms, whatever the given here. The frequency is given, the mu r is given, and the conductivity. Then you get the delta, skin depth. And then you can find out the skin depth and the surface resistance. Surface resistance related to the skin depth is Rs is equal to 1 pi delta into sigma. What is the delta? Is you got the 6.6085 10 to the power of minus 7, and the sigma is given 5.8 10 to the power of 7. You multiply and inverse you can apply, you'll get the 0.02 ohms. Okay. Similarly, the other examples determine the propagation constant of a material mu r and the epsilon r is equal to the given. The conductivity is also given, and the wave is at the frequency 1.6 megahertz. Now the relation is the ratio between of JC and JD, sigma by the omega epsilon, sigma by omega into epsilon naught and the epsilon r. Conductivity is given 0.25 and epsilon r is given, you know the epsilon naught 8.85 to 10 to the power of minus 12. Mu r is given is a 1 only, no need of here. Directly you'll get substituting the values, the conductivity and the epsilon naught, you'll get the value. Next topic is pointing vector or the pointing theorem. Pointing vector and the pointing theorem. Okay. The electromagnetic waves of the energy can be transported from transmitted to the receiver. Everything is a waves is nothing but transmit. It is traveled in atmosphere from the transmitted to the receiver. The energy is stored in an electric field and the magnetic field is transmitted at a certain rate of energy flow, which can be calculated with the help of pointing theorem. The energy stored in the electric field and the magnetic field is transmitted at a certain rate of energy flow, which can be calculated with the help of pointing theorem. As we know, E bar and H bar are basic fields. E bar is electric field expressed in the volts per meter, and H bar is a magnetic field expressed in the amperes per meter. So we can take the product of two fields dimensionally, we get volts ampere per meter square. When you can combine the two functions, volts ampere per meter square or volts and amperes, we can call it as a power. Okay, power nothing but it is a watts per meter square. So this product E bar and H bar gives a new quantity which is expressed as a watts per unit area. Thus, this quantity is called the power density. Okay. So once again, I am saying here this energy stored in the electric and the magnetic field is transmitted at a certain rate of energy flow, which can be calculated with the help of pointing theorem. As electric field and the magnetic fields are the basic fields, the electric field is in the volts per meter and magnetic field is amperes per meter. The product of the two functions of the two fields dimensionally the volts ampere per meter square, and volts and ampere is a watts per meter square or watts per each area. This quantity is called the power density. Okay. As E bar and H bar both are vectors, to get the power density, we may carry out either dot or the cross product. The result of a dot product is always a scalar quantity, but as a power flows in certain direction, it is a vector quantity. Thus, to illustrate this, consider the field is transmitted in the form of electromagnetic waves from an antenna. Both the fields are sinusoidal in nature. The power radiated from the antenna has a particular direction. Hence, to calculate the power density, we must carry out a cross product of E bar and H bar. The power density is given by the P bar is equal to E bar cross H bar. So once again, as E bar and H bar both are the vectors, to get the power density, we may carry out either the dot product or the cross product. But in the result of dot product is always a scalar quantity, but as power flows in certain direction, it's a vector quantity. So the power radiated from antenna has a particular direction. Hence, to calculate a power density, we must carry out the cross product E bar cross H bar. Nothing but the power density is given by E bar cross H bar, where P bar is called pointing vector. Pointing vector. The direction of P bar indicates instantaneous power flow at the point. To get a net power flowing out of any surface, P bar is integrated over same closed surface. So here, E bar is always in the X direction, and H bar is in the Y direction. So E bar is equal to its magnitude is EX into AX bar, and H bar is equal to HY into AY bar. Okay. Now the P bar is equal to the power density or the power pointing vector. The cross product of the two fields, E bar and H bar. E bar is a EX into AX bar, and H bar is a HY into AX AY bar. You can substitute in this power density or the power pointing vector. P bar is equal to EX into AX bar cross EY, not the EY, HY into AY bar. In the cross product, AX and AY will get the AZ. So EX into HY as the cross product of AX and AY is in the order, then we'll get the AZ bar. So P bar is equal to pointing vector, P bar is equal to is in the direction of AZ bar. So EX and HY can write as PZ, scalar quantity, and AZ bar. So P bar is equal to PZ into AZ bar. Indicates that the E bar and H bar and the P bar are mutually perpendicular to each other. Then we know, consider the electric field propagates in a free space given by the E bar is equal to EM cos omega t minus beta z into AX bar. Okay, we know this equation. The positive value, the AX bar only. The E bar is equal to EM into cos omega t minus beta z propagated in the X direction as AX bar, the direction. In the medium, the ratio of magnetic magnitudes of E bar and H bar depends on its intrinsic impedance. Eta is equal to, we know the eta is the ratio between of the electric and the magnetic field. Eta is equal to EM plus by the HM plus or minus EM minus by HM minus. So I'm taking these both are is a positive only. The value is always 125 or the 377 ohms. So we know the intrinsic impedance since eta is equal to under root of mu by the epsilon, where mu naught and the epsilon naught. You can substitute the values. Mu naught is a 4 pi into 10 to the power of minus 7, and epsilon naught you can take is in the free space, because we are considering is a free space, 8.85 into 854 into the power of minus 12. You can calculate these values, approximately you get as 125 or 377 ohms because it is an intrinsic impedance. The eta is equal. Okay. In the medium of the ratio of magnitudes of E bar and H bar depends on its intrinsic impedance eta for a free space. Eta is equal to, in terms of mu naught and the epsilon naught is under root of mu naught by epsilon naught. You'll get the value. Okay. Moreover, the free space electromagnetic wave travels at a speed of light. Thus, we can write as H bar is also. What is the E bar? We already wrote that. Em cos omega t minus beta z into Ax bar. Now, the H bar is having the magnitude is Hm, and the cosine the cos omega t minus beta z, it is in the y direction, Ay bar. Hm is related to the intrinsic impedance, and the electric field is Em by the eta naught into cos, because from this function eta is equal to Em by Hm, and let us say I'm taking the eta naught here. Hm is equal to Em by the eta cos omega t minus beta z into Ay bar. Okay, my students. Now, according to the pointing theorem, the P bar is equal to, pointing vector is equal to E bar cross H bar. E bar cross H bar. What is the E bar? Em into cos omega t minus beta z into Ax bar with cross product of H bar is nothing but Em by the eta naught cos omega t minus beta z Ay bar. Okay. So this is a magnitude only. The Em means Em square by the eta naught, and cos omega t minus beta z and cos omega t beta z is a cos square omega t minus beta z, and Ax cross Ay is a Az bar. Okay, now it is a power watts per meter square. So volts ampere per meter square, or the watts per unit area, Em square by the eta naught cos square. Okay, now we can apply here. The power is equal to, this is nothing but the power density measured in watts per meter square. Thus the power passing particular area is given, the power is equal to power density into the area. Okay, we got the P bar is equal to Em square by the eta into cos square omega t minus beta z into Az bar. To find the average power density, you can apply the integral. See, the P bar is equal to the P average is equal to 1 by t. 0 to t is a limitations because it is z is equal to 0 something, and Em square you can substitute as a power, the Em square by the eta. To find the average power density, let us integrate the power density in z direction over one cycle. Okay, over one cycle, and divided by the period of t of one cycle. So period of actually the power signal is nothing but it's a periodic signal only. The 1 by t, the 0 to t, only the one cycle if I am taking 0 to t only. So full cycle means minus t to the t. Okay. Now the cos square omega t minus beta z into dt. So that is equal to directly the integral cos square, if there is no anything, so we can convert that as 1 plus cos 2 theta by 2. So integral of 0 to t Can also write as EM square by the T into eta is already there, eta naught 0 to T 1 plus cos 2 theta. Cos square theta is nothing but omega T minus beta Z whole divided by the 2 into dt. So we are applying with respect to the T, 1 by 2 into dt is a T only. I'm removing all these functions. Okay. So EM square by eta naught. For the first integral, we'll get 1 by 2 into T. Upper limit is a T and lower limit is a 0. We'll get as T by 2. T by 2 plus for the second integral, we're applying the, with respect to the T, cos, integral cos is a sine. So sine 2 omega T minus beta Z. And we can write as a 1 by 2 is outside 2T. Can remove the T 2 also. The first integral is a T. For the second integral, sine 2 into omega T minus beta Z, and is divided with, we are applying the integral and omega T and the sine. So 2 omega with upper limit is T and the lower limit is 0. Got it, my students? See, after substituting here, T by 2 is upper limit is a T and sine omega T minus beta Z. Substituting upper limit, you get EM square by 2T eta and becomes of the T plus sine 2 into omega small t can represent is a T minus beta Z whole divided by 2 omega minus sine 0 here. The T is a 0. Sine minus 2 into beta Z whole divided by this 2 omega. Okay, sine 2 minus beta Z as a T is equal to 0. That is equal to EM square by the 2T eta multiplying with the T plus sine 2 omega T minus beta Z. Here the sign of minus value, it becomes of is a plus here because it's a sign is odd function. Sine 2 beta Z. Sine 2 beta Z by 2 omega. Okay, so still you can simplify this function. So here EM square by, I take the 2 in the all the functions. Here the 2 means this is a 2 omega and this is also the 2 omega. Okay, EM square by 2T eta capital T plus sine 2 omega T minus beta Z, and sine of minus is becomes here the plus. Okay. Then after sine 4 pi, why I'm saying that is that omega t is equal to 2 pi. You can substitute as omega t is equal to, you can write this function as a 2 pi f into t, that t is also inversely proportional to the frequency. Both are get cancelled. It becomes of 2 pi. Okay. So sine 2 omega t as you can substitute as a 2 pi. And now right here, simplifying the function. So P bar is equal to now the EM square by the 2t eta whole multiply with the capital T plus sine omega t. Omega t now it becomes of 2 pi minus beta z plus sine, this is a 2 beta z whole divided by the 2 omega. Now sine 4 pi minus beta z. Sine 4 pi minus beta z is a minus beta z. Okay. EM square by the 2t eta capital T plus, now it is a sine 4 pi minus, write this as sine 4 pi minus 2 beta z plus sine 2 beta z whole divided by the 2 omega. You know, sine 4 pi minus 2 beta z is equal to sine of minus 2 beta z. Okay, my dear students. Nothing but minus sine 2 beta z. This is a value as per the trigonometric equation. Sine 4 pi minus 2 beta z. Sine 4 pi minus theta as the sine of minus theta, it becomes of minus sine theta. So here EM square by 2t eta and capital T is multiplied, the sine 4 pi minus 2 beta z is a minus sine 2 beta z and plus sine 2 beta z, and here this is a 2 omega is divided. So sine beta z and minus 2 sine beta z cancel, becomes a 0, and here the t and t get cancelled. P bar is equal to the average power P bar is equal to the P average, not the P bar. P average is equal to EM square by the 2 eta. EM square by 2 eta. The P average is equal to EM square by 2 eta. Got it, matters. It's a very important theorem. It's a pointing theorem or the pointing vector to find the average power. So with this, a completion of 5th unit, the theory part also, my students. Okay.